Hello, I am Matthew Isavoli, and today I will be demonstrating how to solve problem number 3 of the packet we have been assigned using equilibriums. So the problem is, two tape spools are attached to an axle supported by bearings at A and D. The radius of spool B is 1.5 inches, and the radius of spool C is 2 inches. Knowing that TB equals 20 pounds and that the system rotates at a constant rate, determine the reactions at A and D. Assume that the bearing at A does not exert any axial thrust and neglect the weights of the spools and axles. In this scenario, both forces that are causing the moment about the axle need to cancel out so it does not rotate. This means that they must create equal but opposite moments. So, the moment about MB minus the moment about MC has to equal 0. So MB is equal to 1.5 inches in the K direction, since that is the radius of the spool, crossed with TB in the J direction, since that is the force, and MC is equal to 2 inches in the J direction, since that is the radius of the second spool, crossed with TC in the K direction, since that is the force which is acting upon it, and those both equal 0. So this could be simplified to 1.5 TB minus 2 TC equals 0. The problem states that the magnitude of TB is 20 pounds in the negative J direction. This information can be used to solve this equation, therefore finding the magnitude of TC. So, what we're going to do is we're going to substitute in the 20 pounds in for TB, and since that is going downwards in the J direction, that's going to be a negative 20. So if you multiply 1.5 times negative 20, you'll get negative 30 minus 2TC equals 0. So add 30 to both sides, then divide both sides by negative 2, and you'll find that TC equals negative 15 pounds in the K direction. The forces applied by A and D must cancel out the forces exerted by TB and TC in order to prevent the axle from moving. So therefore, A in the J direction plus D in the J direction plus TB, which is also in the J direction, have to equal 0. Just like A in the K direction plus D in the K direction plus TC, which again is in the J direction, K direction, have to equal 0. The total moment in this scenario must also add up to 0 as well, so that there is no movement. We will be using A as a reference point. So, 4.5 inches I, which is how far the first spool is on the axis, plus 1.5 inches K, which is the radius of the spool, crossed with negative 20 pounds J, plus 10.5 inches I plus 2 inches J, which again is how far the spool is along the axle as well as the radius of the spool, crossed with negative 15 pounds in the K direction, since TC is the force which is acting upon it, plus 15 inches in the I direction, since D is at the very end of the axle, crossed with D in the J direction plus D in the K direction. That all adds up to 0. And so if we take the cross product of this and this, then we'll find that we can simplify this equation to negative 90 inch-pounds in the K direction plus 157.5 inch-pounds in the J direction plus 15 multiplied by dJ in the K direction plus 15 dK equals 0. The I, J, and K components of the force must be solved individually, thus the equation will need to be split up. So instead of solving it like this, we need to solve for the K and J components individually, so we need to split them into two equations that reflect that. So negative 157.5 inch-pounds in the J direction minus 15 dK inch-pounds J have to equal 0, as well as 15 dJ inch-pounds in the K direction minus 90 inch-pounds in the K direction have to equal 0. So these equations are very simple to solve. They can be solved just like the previous one. So first, add 157.5 to both sides, and you'll get negative 15dk equals 157.5. Then just divide both sides by negative 15, and you'll get that dk equals negative 10.5 pounds in the k direction. The process is very similar for the second equation. Just add 90 to both sides, then divide both sides by 15, and you'll get that gj equals 6 pounds in the j direction. So, as we already established, the forces of A and D need to cancel out the two forces acting upon the spools. So, since we know the forces of D and the forces of T now, we can easily plug back into this equation and solve for the A forces. So, dj is 6 pounds and tb is negative 20 pounds. So that gives us A in the j direction as being 14 pounds. And D in the k direction is negative 10.5 pounds. And TC is negative 15 pounds in the k direction. And so AK must equal 25.5 pounds in the k direction in order to satisfy this equation. And so now we have our solution.